Here we have a problem on exponential equation. That is, we have to solve for x in the given exponential equation. Okay, in my first step, what I'm going to do is I'm going to write the base 4 over here as a power of 2, that is 2 square. So it can be written as 2 square. And since we have x as exponent for this 4, the same exponent we can take for this 2 square, negative 3 times. Here we have 2 to the power x positive 2. Okay, let's consider the product rule of exponent, that is a to the mth power times a to the nth power. So here I multiply two terms with the same base. Whenever I multiply two terms with the same base, I can take the base ones and add the exponents, that is m positive n. Okay, I'm going to do this in reverse order. That is, here we have base a and two values are added at the exponent. So whenever two values are added at the exponent, we can take this base a separately for the first value and second value, and we have to multiply them as we have over here. So the same thing we can do for this 2 to the power x positive 2. There is here we have two values are added at the exponent. So we can take this base 2 for this exponent x and this exponent 2, and we have to multiply them. Then I'm getting 3 times 2 to the xth power times 2 to the second power positive. And the evaluation of 2 to the fifth power is 32 equals to 0. Okay, so now let's consider the power of a power rule in exponents. That is a to the mth power whole to the nth power. So here the base is a and we have exponent m. And for this complete stuff, we have the exponent n. Whenever we have two exponents like this, what we can do is we can do, that is either we can multiply these two exponents, that is a to the power m times n. Otherwise, what I can do is I can switch the two exponents. Then I'm getting a to the nth power whole to the mth power. That is, I'm taking this n as the first exponent and m as the second exponent. Either we can multiply them or we can switch the two exponents whenever we have a term like this. Okay, now here the 2 to the second power whole to the xth power is in the form of a to the mth power whole to the nth power. So what can we do over here? So either I can multiply the two exponents 2 and x, otherwise I have to switch the two exponents. So what I'm going to do is I'm going to switch the two exponents over here. Then I'm getting 2 to the xth power, then whole square, negative 3 times 2 to the xth power. So the evaluation of this 2 square is just 4, positive 32 equals to 0. Okay, now 2 to the xth power, the whole square, negative. So when I multiply this 3 and 4, I'm getting 12. So 12 times 2 to the xth power, positive 32 equals to 0. So here I have 2 to the xth power, here I have 2 to the xth power. So to make the solving process of this equation easier, I'm going to assign a new variable for this 2 to the xth power. So let y equals to 2 to the xth power. So when I assume that when I substitute y equals to 2 to the xth power, wherever I find 2 to the xth power, it can be replaced by y. So here we can plug in for y for this 2 to the xth power, then we have y square, negative 12 times. Here we have 2 to the xth power, we can plug in y for that, negative 12y, positive 32 equals to 0. Okay, now we have a quadratic equation in the variable y. Okay, so how can we solve this quadratic equation? So here, whenever I want to solve a quadratic equation by factoring, so usually we'll try to, if you have a quadratic equation, we'll be trying to solve by factoring. If factoring does not work, we'll be using quadratic formula. I think this quadratic equation can be solved by factoring. Okay, let's try to solve by factoring. So for that, first we have to look at the coefficient of y square. Here it's 1. In that case, I just have to consider the constant term, positive 32. Now I have to get two factors for this positive 32. So that the product of the two factors must be equal to positive 32. And when I add the two factors over here, it must be equal to the middle term, negative 12, which is the coefficient of y. I think negative 8 and negative 4 will work, because when I multiply negative 8 and negative 4, negative times negative will become positive. 8 times 4 is 32. When I add negative 8 and negative 4, it becomes negative 12, which is the coefficient of y. So now to get the values of two values of y from these two factors, what I did is simply I have to change the signs of the two factors. So the first value of y equals to, so opposite of this sign, that is positive 8. The second value of y is so opposite of this sign, that is positive 4. Okay, now I got two values for y. So that is y equals to positive 8 and other values y is equal to positive 4. But y is a variable taken by us. It has to be replaced by the original stuff. That is, we know that y equals to 2 to the xth power. So we can replace y in both the equations by 2 to the xth power. When I do so, I'm getting 2 to the xth power equals to 8. And here I'm getting 2 to the xth power equals to 4. Okay, 2 to the xth power equals to. And so here I'm trying to solve for the variable that we have at the exponent. So whenever I'm trying to solve for a variable that is at the exponent, so what I need to do is I need to get the same base on both sides. Here on the left side, I have base 2. On the right side, I have base 8. But 8 is a power of 2, so 8 can be written as 2 cube because the value of 2 cube is equal to 8. Now I have the same base on both sides. That is, two terms are equal with the same base. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. So I'm getting x equals to 3. Okay, now here let's move to the second equation, that is 2 to the x to power, and this 4 can be written as 2 square. So here the two terms are equal with the same base 2. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. Then I'm getting x equals to 2. So I've solved for x equals to 3 or x equals to 2 in the given exponential equation.